Hello all, welcome to my channel. I'm ready with a new video in which we will be discussing about message brokers, and this is part of the series where we are understanding different components of a data platform that we can use and why we should be knowing that. In this series we are first discussing why we need message brokers and what message brokers we can use in a Kubernetes platform. So let's get started. So first thing first, what is a message broker? In terms of a plain definition wise, a message broker is something which enables communication between two microservices or services. But it is not a strict definition. Like simply you can say a message broker is something which allows systems to come exchange messages. So in plain and simple terms, we can say that. So if you see the picture, like let's say if you have multiple, although we have said producer and consumer, it can be service one, which publishes some event to a message broker, and there is a service two which consumes that message. So that we can say producer is a and consumer is a specific term used for point to uh, many communication because there can be one sub publisher and there can be multiple consumers of that particular message. So yeah, that is point to consumer, but we can also have multiple other patterns as well. Like we can have point to point, we can have point to many, we could have publisher and subscriber. So there are different mechanisms in which message broker is used. We will see that those things in some other video. In this video, the idea is to see what a message broker is and what are the tools available for us to implement a message broker. So after the definition, let's understand why we need message brokers, or what is that message broker help us with. So for example, first thing that it helps us with is decoupling producer from consumer, or we can say decoupling the systems which needs to exchange data. So what happens is, let's say if you have one service and there is another service, let's say in this case here you have a producer app and there is a consumer app, and let's say this producer wants to send some data to this consumer. For that transaction or for that message exchange to happen, both producer and consumer should be up at the same time. So if let's say while producing and it's sending it to this consumer, and if this consumer is down, that message is lost. It is not available. And other way around as well is possible. It might be that the consumer is available, but the producer itself is not able to produce at the time when it is needed by the consumer. So to decouple this, we have a concept of message broker. This makes these two systems independent of each other. So the service or the producer or the publisher can send a message to a message broker, which will store that message for the time being, and a consumer will consume and delete it or discard it depending upon how they are configured it. And that makes this system totally independent. Like for example, if there is a huge number of requests coming from the producer side, we can still buffer it and the consumers can process it at their own speed. Or it can be other way around. Let's say the producer is producing, let's say, messages at, let's say, 10 messages per second, and we want to process all those in parallel, so we will have 10 consumers and consume that message and process it in parallel. So that's what the other benefit of it is, to making the parallel processing, scaling the producer and consumer separately. That is one other benefit. Then we have it will reduce the pressure of the downstream consumers. So how it happens is, let's say this consumer is only able to process 5 messages per second, and if let's say suddenly there was a spike and the producer produced 10 messages per second. If we had direct coupling, then at that time consumer would have died and it would have lost the messages. But because we have message broker, so all those 10 messages will be stored in message broker, and this consumer will keep on processing up its own pace. So that the pressure which earlier it will have if it was a direct communication to process all those 10 messages in the quick time is not there, and hence it is more easy or more suitable for us to try out things. Okay. And then it also prevents data loss, as I mentioned, that if the consumer is not there, still the message will be there, and when consumer comes up, it can process the message. So there is no data loss. So once we have seen what a consumer or a message broker is, why we need it, what message broker helps us with. Now let's see what are the options we have while working with Kubernetes platform. What message brokers we can launch on a Kubernetes platform to uh, provide this capability of decoupling systems using a message broker. So first, thing which comes to our what you call, which comes should come to our purview is KubeMQ. Uh, the reason this I have listed it first is because it is very much a Kubernetes product itself. It is a Kubernetes native supported project. So KubeMQ is a Kubernetes native enterprise grade message broker, and also it can access message queue or message streaming with ready to use connectors and control center. So it also has a good UI that we can see to see how many messages are there, how many queues are there, how many pubs up, different types of mechanism, what is the rate and stuff like that. So this is something which is available in KubeMQ. It is as I mentioned, it is very much native to Kubernetes. All the things which are needed in means this supports Kubernetes fully. It is very means it is super fast, small, and lightweight. It only has a 30 MB memory footprint per instance in Docker container. So it is very lightweight. Supports both FIFO-Q, RPC command, PubSub, persistent event store, pub/sub events, and query messaging patterns. So it has different patterns that it supports, and it has different. This is where we were talking, right? It can be a queue, it can be a RPC command. So it's all those things are supported in KubeMQ. It supports even WebSocket transport protocol. It supports REST, gRPC, and TLS. So all those messaging protocols which are needed are supported. Message delivery support for is at least once, at most once, and exactly once. So it can support all three models. Like we can say configure our queues to support at least once. So a message has to be delivered at least once. It can be delivered more than once as well. So that's what the at least one. Then we have at most one. So we may say that okay, we have to have only one message. The consumers can't handle duplicate. So in that case, we can use at most once. And exactly once is slightly more constrained one, like we can't have more than one, we can't have less than one. So we either we deliver the message or we don't deliver the message. So that's the exactly one semantic. So the message will be only delivered once, but they will be delivered at least once for sure. They will not be delivered more than once. So that's the exactly once model which is there, which is supported by KubeMQ. And this KubeMQ has a lot of SDKs for integrations. Like the SDKs are available in Go, Python, Java, sorry, C Sharp, PHP, Ruby, Node, jQuery. So this is very versatile and very wider reach solution. It has certain limitations that it is not, as of now, it is not integrated with any SQL systems. And there is no official community which is thriving. Means in a sense, it is there. There are people who are there actively helping people, but there is not a very vibrant community. So if you face any issues, you might have to dig deep into the code and find out what is going on. And also this is another issue with is the external DNS registration, which is something which is not straightforward, requires certain workaround in this case. So KubeMQ has that limitation, and this has a Helm chart. We can simply install using the Helm community. KubeMQ is both. It has an enterprise support version as well as a community version. So if you are trying to test it out of yourself, you can go ahead and look at the KubeMQ's community charts, and then also leverage the full enterprise support as well. So Helm chart is available. We can install Helm, and then we can provide. So let's say if you are using the Kubernetes KubeMQ cluster with enterprise support, then you will provide your license key in here. Then and that way you can install it and then test it out. But if you want to do it at testing, you can simply use the Docker container to see how it works and how you can build the applications in local before moving into production. Use cases. This is very much an enabler for creating a multi-edge cloud systems. For example, we can have edge nodes on a KubeMQ cluster where for example, let's say IoT devices. We can use this to upload files. Let's say we have uh, production companies. Let's say we have power plants at different locations, and each of the location power plants wants to upload something to that centralized KubeMQ server, let's say as a file. So the file first gets uploaded to the local node, and then from local node, we create a metadata, publish the event to the queue, and then it gets uploaded to a centralized cluster where there is another queue where it says that, okay, I have received this metadata from this particular site, and then based on those attributes, certain consumer will come up and consume that PDF file. So that can be one example of using this message broker. Then we can have multi-stage pipelines built and create task queues that can be used that we can use KubeMQ to create. And we can have pub and sub publisher and subscriber mode of data exchange if we want. We can also implement that using KubeMQ. So these are the things that we can do with KubeMQ. Uh, then there is another service called NATS, which is it is very popular for its simplicity and speed. It has been used at many companies at a very large scale, and it's a battle tested one. Its throughput numbers and its latency numbers are uh, very much versatile for most of the use cases that are out there. Uh, it has a self-healing nature as well. It automatically recovers from failures. It has a jet stream concept, which is persistent for the queue. If we want, we can have that. And resource-wise, also, it has a very lower memory footprint, very versatile in a sense. It is very fast and efficient. There are some challenges like scaling. It can be slightly trickier because it runs at stateful set and when we have things running as, let's say, a deployment or a replica set, it's very easy to scale it up and down. But when it is comes to stateful set, it is slightly difficult, not that difficult, but yes, it is slightly difficult to auto scale it. Requires fine tuning. Storage and resource allocation needs careful configuration because this can quickly spin out of control as well. Um, the challenge is that it doesn't have that many integrations as RabbitMQ has or Kafka had. So this is something on integration wise, we will have to write a lot of scaffolding code for us to integrate with our system. Otherwise, this system is very good. Like if you know, Astronomer is an project which offers platform for airflow, and it uses NATS internally to communicate between microservices. So that is one example where it is used. Uh, as use cases, low latency messaging if is needed, or simple pub-sub workloads are needed, then we can use NATS. This brings us to the next tool, which is out there called Memphis.dev. So Memphis.dev is built on top of NATS stream that we were discussing just now, but it is a whole managed platform which is there if we have any use cases for message queue or streaming platform that we want to have. It has four different things, like it has core, it has the controller, it has stream consumption as well. So it has different components, and it can be deployed on Kubernetes, full support with Kubernetes. It supports ordered and immutable event logs as well. So we can treat it as a Kafka alternative as well for small scale. It has features like message persistence, message filtering, message batching. So this is an enterprise kind of platform which offers message broker as a service completely running on top of Kubernetes and built on top of the proven record of NATS. And we can install it using Helm. This also comes very nice, like we have a namespace, we can provide the versions and stuff like that. One important note is Memphis.dev is no longer being an active project from Superstream team, which was earlier funding it. They made it available for all, but for the last 9 months or 1 year, I have not seen any commit happening in their GitHub repo. So that is something needs to be noted, that there is no active work going on this Memphis project. This brings us to our next tool that is out there that we can use as a message broker is RabbitMQ. Uh, it is very much enterprise ready. It has been in production at many large companies as a message broker in on-prem systems as well. It has a solid support for Kubernetes. Like it has an operator like RabbitMQ cluster operator is there that we can use to just spin up the queuing capability. It has been, as I mentioned, it has been used in production for decades. What are the challenging is this is it is the resource consumption is high for this compared to NATS, and latency is it is slightly slower than Kafka and or NATS for that use for that time being in cases where we have massive workload. So this is something which is to be noted. And how do we create an operator and stuff like that is defined in here. Like you can install the Helm chart, then we can define a role, we can define the role binding, and then we see the okay, kubectl apply, and then we define the NPI kind. Kind is RabbitMQ cluster, and this will create a RabbitMQ cluster for us, and then we can start consuming the message and producing the message. Use cases, it is enterprise messaging with high reliability. We can use it. Complex routing requirements if we have, or the queuing needs we have, we can use this. Applications requiring strong delivery guarantees can also be used with RabbitMQ. So as RabbitMQ was there, then similarly we have AutoMQ as well. AutoMQ is a Kafka native, Kafka compatible solution which uses tiered stories, as well as it has. So what it tries to do is it tries to have the same mechanism of doing things as Kafka would do, but at a lesser cost and higher throughput and higher numbers, because it uses object storage as its persistence layer, not the disk based one. So it uses hybrid. It has a disk base, but that only stores the live data. So that is out there. It is AutoMQ on K8s. If we implement it, it eliminates the need of maintaining Kafka's elasticity and everything. We can scale up and scale down the brokers independent of the node capacity that we have for the messages. So why we choose AutoMQ? It is massively scalable. It has a durable storage. It has a rich ecosystem. Like it is simpler to integrate with Apache Flink, Spark, or Elasticsearch. Partition reassignment are very fast in this case because it does not use a leader node based system. It simply any node can become a leader for that matter. And it has a continuous traffic self balancing that we can leverage to help us with throughput numbers that we need. Use cases for AutoMQ is high throughput event streaming. If we need real time analytics and monitoring, we can use this. We can also use this for large scale microservice communications. So it is uh, even Apache Kafka can be deployed on K8s with the following command. So this is how we deploy Kafka, and only thing is that we are using StreamG's Kafka node, but any node. Similarly, we can install AutoMQ on Kubernetes as well. Just we will use the image of AutoMQ rather than from the open source Kafka. So this is their. Then we have Redpanda. So Redpanda is a streaming platform which is free and open source. It is compatible with Kafka API. I think they have also some license change recently, but still it is considered an open source project. And again, it is something similar to how Kafka does. So it has slightly different strategy. Like instead of zookeeper, it uses bookkeeper, and hence it has certain external dependency as well. For example, external discovery is limited to node port. We can, although the engine is written C++, it has a lot of Java-based code which does have a JVM overhead. We can install it using Helm chart. Use cases, event streaming, message brokering, log aggregation can be used. It's a good use case for these type of systems. Then we have Pulsar. Again, this is something which is similar to Apache Kafka, but it is known for its multi-tenancy and geo-replication. So if we need cross-region data distribution, Pulsar is good solution. Challenges is that it is very complex. It requires bookkeeper, zookeeper, both, as well as it has a lower adoption rate compared to Kafka. So the community support might be less. Hence, also there will be fewer third-party integrations which are directly natively available. Sometimes we might have to write it ourselves. And there are many moving parts, so that makes it slightly complex to operate, but it also has a Helm chart that we can use to install in a cluster. So now comes the question that we have seen different tools, which one to use in which use cases. So yeah, this is I will say it's a summary of the blog. So if we want to have completely indicated native solution, we use KubeMQ. If we need fast, lightweight messaging, then we use NATS. If we have traditional enterprise messaging requirements, we use RabbitMQ. For high throughput event streaming at low cost, we have AutoMQ. For high throughput and event streaming but lower latency numbers, Redpanda. And if we need multi-tenant geo-replicated workloads, we can go ahead with Pulsar. I have not mentioned Memphis, although it's a very great product. It looks very promising, but the reason I have not mentioned is because in the last 8 to 9 months or for a year almost, there has not been an active war going on. So I don't know what is the future of Memphis or Dev. So that's why I did not include it in the final. Uh, list of tools which are available, or lots of tool we should be looking in different scenarios. So yeah, this video was it. That's it for this video. We have seen all the options that are available. If you like this video, do share and spread the word. Have a nice day. Thank you.